Gofila is a dóigh popper hain ceiste hocht. The company uses waterproof paper to make disposable conical drinking cups. To make each cup, a sector AOB is cut from a circular piece of paper of radius 9 centimeters. The edges AO and OB are then joined to form the cup as shown. The radius of the rim of the cup is R and the height of the cup is H. So that's all the information really that they've given us in the diagram. So for part A, by using R squared in terms of H, show that the capacity of the cup in centimeters cubed is given by the formula volume is equal to pi over 3h 81 minus h squared. So really they've given us the first thing that we need to do. So by expressing R squared in terms of h. So that's what we're going to do first. And then we're using that to show that the volume is equal to pi over 3h 81 minus h squared. So to do this, really, we're going to use a diagram that's going to be a combination, really, of the two that they've given us. So I'm using the right angle triangle with the radius and h. And on the other diagram, they've given us 9, and that's really going to be the slope of the conical cup. So now we have information we can write R in terms of h. Because using Pythagoras' theorem, we know that R squared plus h squared is going to be equal to 9 squared. R squared is therefore equal to 81 minus h squared. And we're happy because this is one of the parts of the formula that they've given us, so we know we're on the right track. So for the formula, we have the volume is equal to pi R squared h over 3 for a cone, or 1/3 multiplied by pi R squared h. So we're filling in what we have for R, which is 81 minus h squared, and for h, so just to rewrite it exactly in the way that they've asked us to, pi over 3 multiplied by h multiplied by 81 minus h squared. So for part B, they tell us there are two positive values for h for which the capacity of the cup is equal to 154 pi over 3. One of these values is an integer. Find the two values. Give the non-integer value correct to 2 decimal places. So essentially just translate what they've told us into maths. They've told us that the volume, which we have in this format, we can let it be equal to 154 pi over 3. And when we do, we're going to find two values for h. Two positive values. So first of all, I'm just going to write that pi over 3, 81h minus h cubed. So I've just simplified there what we have and multiplied the h into the bracket. And this is equal to 154 pi over 3. So now we have an equation with h being the variable, and I want to find the values of h. They told me that 2 are positive. If I have h cubed, I know I'm going to find 3 values for h, so I'm assuming that one of them is going to be negative. So out of 3 roots, 2 positive, 1 negative. Out of the positive, they've said that 1 is an integer, and then we have to give the other one that's not going to be an integer to 2 decimal places. So essentially, we just have algebra. I need to find 3 values for h. So the first thing that we can do is multiply both sides by 3 in order to cancel 2 3's. Divide both sides by pi. So just to simplify, 81h minus h cubed is equal to 154. So I have h cubed minus 81h minus 154 is equal to 0. If I had just brought the 154 over to the left and had minus h cubed plus 81h and minus 154, I'm still going to get the same solutions at the end. I now have a cubic equation and I want to find 3 values for h. So my first step is just using trial and error, find the integer root. So we can let h be equal to 0, or sorry, h be equal to 1. When I substitute that in, I'm going to get 1 cubed minus 81 multiplied by 1 minus 154. This does not give me a 0, so therefore 1 is not one of the roots. So I'm going to try h is equal to 2. I get 2 cubed minus 81 multiplied by 2 minus 154. This is equal to 0, so h is equal to 2 is one of my roots. Therefore, h minus 2 is one of the factors. Don't need those brackets actually. And we're going to divide it into our cubic. So h cubed minus 81h minus 154. So now we just have long division. H into h cubed, we get h squared. And then multiply h squared by everything. Subtract the lines, we're going to get minus 79. So I'm just going to pause here. I've forgotten about my h squared. So I'm going to just put in, so I don't make any mistakes, 0h squared. And then I have my minus 81h here and my minus 154 plus 154. Okay, so because we can't subtract the h squared from the h, so when I subtract the lines, subtract this one, I'm going to end up adding that. I'm going to get 2h squared and bring down the minus 81h and continue on with my long division. So now I have a quadratic, h squared plus 2h minus 77. Can't factorize, so I need to use my minus b formula. A equals 1, b equals 2, c equals minus 77. So I've taken just a few shortcuts to run through. If you have any questions on these two solutions, or if you've done it out and made a mistake, just let me know so we can make sure you're okay with using the formula. Hopefully we all are. So back to what they've told us. They've told us that there's two positive values for h. So we found one of them using trial and error, and that was h is equal to 2. We found the other positive value, so I just changed it to x, but what we found is h, so 7.83, and we're disregarding the negative value. They've asked us to give our answer to two decimal places, so that's what we've done with 7.83. C. Find the maximum possible volume of the cup to correct to the nearest centimeter cubed. So to find maximum volume, we need to differentiate the function that we have for volume. So we know that the volume is equal to pi over 3, 81h minus h cubed. Just to make it easier when differentiating to avoid any little mistakes, I'm just going to multiply pi over 3 in. So when I do that, I'm going to get 27 pi h minus pi. So when I do that, I'm going to get 27 pi h minus pi over 3 h cubed. So when I differentiate, dv dh is going to give me 27 pi minus 3 pi over 3 h squared. So when I just simplify again, so when I let my 27 pi minus pi h squared be equal to 0, I'm going to find maximum and minimum points. and solve for h. So divide both sides by pi. H therefore is going to be equal to square root of 27. So h is going to be equal to 5.196 or minus 5.196. So because the two values are the same, we know that the maximum volume is going to be 5.196. So just to note that usually we can also find the second derivative to determine whether it's a maximum point or a minimum point. So if we find the second derivative and we fill in the values, we want to see which is positive and which is negative. So if it's positive, it's a minimum point, and it's maximum, it's a negative point or negative value. So sorry, just going back to what we have here. It's not the maximum value we found maximum h for this volume. So the volume is at its maximum when h is equal to 5.196. So we're going to fill this into the formula for our volume in order to find that maximum volume. So we have the volume, just T for tert or V for volume. I'll try and use the same one. We had simplified it to be 27 pi h minus pi over 3 h cubed. So just filling in this or square root of 27 just to simplify. So we get 27 pi multiplied by square root of 27 minus pi over 3 square root of 27 cubed. This is going to give us approximately 294 centimeters cubed. So that's the maximum volume of the cone. D. Complete the table below to show the radius, height and capacity of each of the cups involved in parts B and C above. In each case, give the radius and height corrected 2 decimal places. So they told us directly to use B and C, but we're also going to be using what we have for A. So in part A, we confirmed that that is the formula for the cone that we're given. And we also know that we have r squared is equal to 81 minus h squared. So if we have h and we need to find r, we know that we can, or vice versa. So with B, we know we have two values for h, and with C, we know we have the maximum volume. So I'm going to fill in some of these values straight away. So for part B, we had the height of 2 and the height of 7.83. And for part C, we had the maximum value was 294 centimeters cubed. We'll just use our units as well, just to make sure we're including everything. So we're using part A to find the radius. Radius squared is equal to 81 minus h squared. So if I know what h is, then we can use this in order to find something to fill in for the radius. So when h is equal to 2, we have radius squared is equal to 81 minus 4, which is equal to 77. So therefore the radius is equal to 8.77. So again, just not forgetting about the fact that they told us to give everything to 2 decimal places. So we have 8.77. So now when h is equal to 7.83. Again, radius squared is equal to 81 minus, so h squared is going to be 61.3089. We only rounded 2 decimal places at the end to make sure we're being as accurate as possible. So 4 decimal places until then is okay. 19.69 for r squared. So r is going to be equal to 4.43. So in part C, before we found 294 centimeters cubed, we found the height, and it was 5.196. So to 2 decimal places, that's 5.20. And again, we're going to use 5.20 in order to find the radius, just as we have done for these values. When we do that, we're going to find 7.35 centimeters. E. In practice, which one of the 3 cups above is the most reasonable shape for a conical cup? Give a reason for your answer. So the most important thing is that we give the reason for the answer, because really, as long as you can give a logical reason, you should get full marks. But obviously we are looking for one that's more suitable than the others. So really for the first one, if we look at 8.77 centimeters and 2 centimeters, if we make a cup that has that much of a radius and the height is only 2 centimeters, it's not going to work very well. The next one, the height is bigger than the radius, it's going to be more suitable. And the last one, again, the radius is much bigger than the height of the cup. So these two, the first one and the last one, they're going to be much too shallow and much too wide at the brim in order to work correctly. So the middle one would be the best choice. So just to make a note of our answer, the middle cup. Even maybe putting an arrow or highlighting or something just to make sure we're identifying the correct one. I think middle cup is fairly self-explanatory. And then just writing that the others are too shallow. And too wide at the brim. And on to part F. For the cup you've chosen in part E, find the measure of the angle AOB that must be cut from the circular disc in order to make the cup. Give your answer in degrees correct to the nearest degree. So we're going to mark in the angles. They want us to calculate this angle here. I'm going to call it theta 2 because I'm going to be actually finding theta 1 and then just subtract that from 360 to give the angle that they've asked us for. So we're using the middle cup, making a note of the dimensions. We've 4.43 for the radius, 7.83 for the height. We know that for all of these cups, the slant of the cone, I'm going to draw a sketch now, but the slant is equal to 9 for any of them. So I'm going to draw a sketch of what we're going to use. I'm filling in the dimensions that we're using. We have 9, 4.43 for the radius, and 7.83 for the height. So if I need to find this angle, what I can relate it to is the area of this sector here. Because I know that in order to find the area of that sector, I use this angle theta 1 in the formula. So if I can use that formula and find theta 1, then I'll be able to find theta 2. I also know that the area of this sector here is equal to the curved surface area for the cone that I have. So using our formula book, the curved surface area is equal to pi or L, where L is the slanted side or is the radius. So I can find the curved surface area of the cone, let it be equal to the surface area or just the area of the sector that we have here. If we let them be equal to each other, then we can solve for theta. So let's just go ahead and do that. So pi multiplied by r, which is 4.43, multiplied by 9, we have 39.87 pi. So sorry about the scribbly writing. I think it's just a long video, so it's starting to slow down. Anyway, area of the sector, we have theta over 360 pi r squared. So for the area of the sector, we're using 9. So we're saying that they're equal. So we're saying the curved surface area is equal to the area of this sector. So I'm going to let them be equal. Divide both sides by theta. Multiply 39.87 by 360. It's going to be equal to 81 theta. So theta is going to be equal to 143.2 divided by 81, which is going to give us 177.2. So this is our theta 1. We've found this angle in here, so we're going to take that away from 360 in order to find the angle that we're looking for. So that angle that they're asking us for is going to be equal to 182.8 degrees.